Hello, my name is METİN. This is 343rd part of explanation of my theory. Yes. What do you think these three graphs in common? And which graph has the anomaly that distinguishes it from the other two? X-rays, stars, relatively temperature, X-rays relatively applied voltage, and astrophysics graphs here. A continuous spectrum with the smallest minimum wavelength must represent most energetic electrons or stars. Okay. At the greatest velocity. As I put forth before, here, this is my formula for applying voltage, here temperature, etc. As I put forth before, smallest minimum wavelength or shortest shortened wavelength of a continuous spectrum, okay, is inversely proportional of the source, here electrons. Eventually electrons are sources of all light. Okay, it's source velocity. Here my formula, remember. Now, for applying 10,000 volts, electrons gain velocity. Here, their shortest shortened wavelength, minimum wavelength. But as applying voltage increase, electrons velocities increase also, and their minimum wavelength now close to zero, smallest minimum wavelength, here. But when you apply 30,000 volts, electrons will be will have greater energy, more energetic, and their velocities will increase. Here, maximum voltage, 30,000 volts, and in this graph, and that last graph has smallest minimum wavelength. Relatively, each source electron has greatest velocity. Here, 1000 Kelvin temperature, here minimum wavelength point. Greater temperature 2000, here minimum wavelength. Greatest temperature 400 Kelvin, here smallest minimum wavelength. Corresponds greatest electron velocity. But now, here, astrophysics graphs comparison. Z equals 4 have superluminal velocity because they say universe expands at this velocity. Okay? For this graph, Z equal 4 represents most greatest velocity of galaxy or star here. Okay, Z equal 4 greater than Z equal 1. Blue one, wait a moment please. Wait a moment please. Yes. Blue one, Z equal 1, and black one, Z equals 0. This black graph, Z equals 0, relatively at rest, not expanding background. Here Z equal to 4 has greatest velocity, and here left side for X-rays, for stars. These are the rules that I put for the laws of these graphs. I explained before. But how can it be? Maximum velocity of source, minimum, smallest minimum wavelength. Maximum velocity of source, smallest minimum wavelength. But here maximum velocity source, how can it be greater than smallest minimum wavelength? This is wavelength side. You see? Okay. How can a graph that is supposed to represent the greatest superluminal Z equals to 4 fastest galaxy contain the greatest minimum wavelength? It must be there. It must be smallest minimum wavelength. Okay? Yes. And how can a graph that is supposed to represent the 0 Z motionless galaxy contain the smallest minimum wavelength? This is wrong. This is wrong. Yes. Because as the speed of source increases, minimum wavelength of the continuous spectrum decreases, and vice versa. Like this, it must